Students, digital to analog conversion की techniques की बात चल रही है, and we discussed the amplitude shift keying. Now we are going to talk about the frequency shift keying. Students, as I told you, in the case of FSK, the frequency of the carrier signal is varied to represent the digital information that we need to send. अब students, frequency जो है वो एक signal element के case में, when we are talking about binary, for example, it will remain constant, while for the next signal element, this frequency will vary. Students, an important point to note, as you already know, frequency is varied, amplitude and phase, they remain constant. Example study करेंगे of the binary frequency shift keying, binary FSK, and as you can see, the baud rate in this case is 5, our bit rate is 5. Once again, we are talking about 5 signal elements, and what we have is for a 1, our carrier frequency remains the same. For a 0, we vary the carrier frequency. So for every 1, we have got a certain frequency. Every single 1 bit, we have got a certain frequency. And for a 0, we have got a different frequency. आपको आगे चल के मैं बताऊंगा कि for one of these 2 bits, when we look at the implementation, you'll see that one of these 2 bits, the frequency is exactly the same as the carrier frequency. We don't touch it, we don't change it, we don't vary it. For the other signal element, we change it to represent a change in the signal element. Students, गौर कीजिएगा, amplitude throughout remains constant. So your amplitude is constant. Once again, your phase remains constant as well. The only thing that's changing in FSK is your frequency, and we'll see in the implementation how it changes with reference to the carrier signal. Students, in the bottom you can see that we can think about the FSK or the binary FSK as being made up of 2 different carrier frequencies. In this case, we have shown them as F1 and F2. So students, we use the first carrier if the data element is 0. This is what we use for a 0. And we use the second carrier F2 if we have got a data element of 1. Students, normally the carrier frequencies are not so small. Normally the carrier frequencies in real life, they are very high, and the difference between these 2 frequencies is pretty small. Students, the middle of these 2, if you take a delta F1, F2, then in this case the middle of one bandwidth is F1 and the middle of the other bandwidth is F2, and both F1 and F2 are delta F apart from the midpoints between the 2 bands. Therefore, students, the difference between the frequencies is 2 delta F. And students, in this case, the bandwidth is equal to 1 plus D times capital S plus 2 delta F. Students, मैंने आपको introduction में, when we started the discussion of digital to analog conversion, I told you the exact same point. So for every single technique that we are going to be talking about, digital to analog conversion, the bandwidth is directly proportional to the signal rate, except for the case of FSK, because we need to add the difference in the delta, the difference in the 2 frequencies, and that gets added to this bandwidth, and therefore for the case of FSK, this does not hold true. Bandwidth is not proportional to the signal rate in the case of FSK.